Every morning without fail, it rises. We take it for granted. A light source, a source of warmth, something to avoid staring at directly. But the sun is not just a star. It is our star. The reason Earth has oceans, atmosphere, seasons, and life. And when you actually look at what it is, what's inside it, how it works, how big it truly is, it becomes one of the most extraordinary objects you'll ever learn about. Today we're doing the full picture: size, structure, energy, surface, atmosphere, everything you need to know about the sun. Let's start with something that will immediately reset your sense of scale. The sun's diameter is about 4 million kilometers. Earth's diameter is about 12,700 kilometers. That means you could line up 109 Earths side by side across the face of the sun, or fit over 3 million Earths inside the sun's volume. All 8 planets of the solar system combined, Mercury through Neptune, account for less than 0.2% of the total mass of the solar system. The sun contains the other 99.8%. It doesn't just dominate our solar system, it is our solar system. Everything else is just debris orbiting a star. The sun is a giant ball of plasma, superheated gas so hot that electrons are stripped from atoms entirely. It's made up of about 73% hydrogen and 25% helium, with trace amounts of heavier elements like oxygen, carbon, and iron making up the rest. And it has distinct layers, each with its own temperature, density, and behavior. At the center is the core, where temperatures reach 15 million degrees Celsius and nuclear fusion converts hydrogen into helium, releasing the energy that powers the entire sun. The core extends about 25% of the way to the surface. Surrounding the core is the radiative zone, where energy travels outward as photons, bouncing between particles. A photon can take 100,000 years to travel from the core to the edge of this zone. Next is the convective zone, where hot plasma rises, cools at the surface, sinks back down, and rises again, like a pot of boiling water, but on a solar scale. Then comes the photosphere, the visible surface of the sun. It glows at about 500 degrees Celsius and is covered in granules, convection cells the size of Texas, constantly churning and reforming. Above the photosphere is the chromosphere, a reddish layer visible during solar eclipses, home to solar flares and prominences. And finally, the corona, the sun's outer atmosphere extending millions of kilometers into space, mysteriously hotter than the surface, over 1 million degrees Celsius. Every second, the sun converts about 600 million tons of hydrogen into helium through nuclear fusion. In that process, about 4 million tons of matter is converted directly into energy, according to Einstein's ELMC2. That energy begins as gamma rays in the core. It takes roughly 100,000 years to work its way to the surface, then just 8 minutes to travel from the sun to Earth. Sunspots are dark patches on the photosphere caused by intense magnetic field concentrations that inhibit convection. They're cooler, around 500 degrees instead of 500, making them appear dark by comparison. Sunspot activity follows an 11-year cycle. At solar maximum, the sun teems with sunspots and is far more active. Giant loops of plasma called prominences arc hundreds of thousands of kilometers into space, following magnetic field lines. When magnetic field lines snap and reconnect, they release enormous bursts of energy, solar flares, as powerful as 1 billion hydrogen bombs in minutes. The sun is 6 billion years old and has roughly 5 billion years left, stable, warm, and reliable. A middle-aged star going about its business and making all of this possible. In the next video, we're going deeper into one of the sun's most dramatic behaviors: solar flares and space weather. Can they actually destroy Earth? If you enjoyed this, a like helps the channel enormously. Subscribe and drop a comment. What sun fact surprised you most today? See you in the next one. Keep looking up.